Right, so I'm well ready to test this power supply. I have put LEDs on here prior. I think that was 2 months ago that I did this. And other than that, I recapped this. I'm gonna put the power supply here for now, so I have something to power this. I do think I will eventually replace this with a power supply of my own making, simply because newer modern components are a bit more reliable, stable, and higher quality, instead of 50-year-old power supply electronics. So yeah, now it's time to get back to the rack. What I first need to get working is the keyboard scanning. It is 15 volt. In fact, all the logic is 15 volt, which is really unfortunate. I was really hoping it was 5 volts, but well, beggars can be choosers, I guess. And yeah, I'm gonna need to make an interface to connect this to an Arduino or an Atmega for MIDI. Once I've got that working and I got some waveforms coming out of this, I can start doing the rest. Okay, the beast is powered on, and I connected some testing wires to upper 1 and the C node for the key scan, so I can put a little diode in there, and also the two 8-foot outputs of the two oscillators. And having put in the diode, yes, that indeed looks like stuff is happening. If I remove the diode, it stops happening. So, yay, stuff is happening. Now, as you can see, when I zoom in, we have the key scanning up here. It's kind of an interesting pattern. And we have the waveform below here, and you can see the serial processing in action, where it's all just little pulses. And if I zoom out again, you can actually see the waveform. Okay, so it's getting even more fun. So there are 4 stages. Stage 1 and 2 are the important ones. Stage 1, I explained before, all the nodes terminals are pulled down to -15, and any octave terminals that are connected via a key are then also pulled down. So then the chip knows, okay, that octave is being played. Then for the nodes, what it does, it actually pulls the octave terminal back up, and then it checks the node terminals to see which one have been pulled up from -15 to ground. So it's a bidirectional system. Okay, I'm actually very much in luck. I was thinking the signals that the key scanner sends to the rest of the circuitry are way simpler to replicate, and would just bypass the key scanner just entirely. Of course, the reason I was not actually wanting to do that, because that would involve soldering on these very rare Yamaha ICs, which kind of is a big no-no. But I discovered that all the signals that I need are going through all these jumpers, which is incredibly convenient, because I could just cut these through and connect my own controller to it, of course with transistors to change the levels to the 15 volt. That would be very non-invasive, and if I ever want to go back, I can just reconnect these jumpers again. Right, I had to do some sneaky things. Fit the Arduino on here. It's bolted in place to this metal plate over here. Turns out these are M3 screws, so that saves. Tried a few positions here and there on the board, but ultimately I want it here, because when this board is in the rack, it still needs to be accessible. I want to be able to push a USB connector in there so I can program the thing whilst not taking apart the entire tower of power. There is one problem, however. The Arduino runs on 5 volts, as you may know. The Yamaha, well, in this case, this board only has 15 volts, or specifically minus 15 volts. Now, I was thinking, well, I could use minus 15 as ground, and the ground is positive 15. Of course, I need to regulate it down to a lower voltage. I could use the internal voltage regulator of the Arduino. Yeah, but then I realized something about the ground. The USB port. If I were to connect my USB port to my computer, there's suddenly a 15-volt difference between it and my computer. And I'm not sure how well that will fare for the USB or for the Arduino in general. Since I'm no longer using the key coder, I can actually use the keyboard scanning pins on the big connector and thus on the motherboard for other purposes. In this case, I've reused CL, which has a jumper over here that I removed, and I've instead connected a yellow, correct color code, wire for 5 volts to the 5 volt input of the Arduino. That way I can also connect it here on the motherboard, the 5 volt, and then the Arduino is situated correctly. Right, the procedure of making a little daughter board for the voltage conversion has begun. Okay, almost done, but I didn't realize the LM324s are sticking out a little bit. They're a little bit longer than the sockets. So I had to put another socket in a socket to fit the last one in. Almost forgot to add the connection and the switch for the MIDI. So this switch disconnects the MIDI from the serial port, so when you're programming through USB, it doesn't mess things up. Think it's about ready. Never mind me, just installing the PCB. Okay, mildly terrifying, but I've installed the PCB with the Arduino. I've programmed the Arduino to play A440. And, well, I mean, I'm seeing seeing sine waves from both the waveform generators. So I just gotta measure the frequency now. I'm gonna low pass filter it and see if I can extract the actual sine waves. Okay, I've hooked up some testing wires because it's impossible to get the probes in there. And here we have the clock that the Arduino is receiving. It seems to have a little bit of DC wobble. Not sure what's up with that, but the minimum is around 300 millivolts, the maximum around 3.8 volts. So, and it's 37 kilohertz more or less. So that is perfect. This is the clock that gets sent to the Arduino for the external interrupt. And this is one of the signals going to the rest of the circuitry in the E-70. And let's see. So that's between around 800 millivolts to minus 8.8 volts. It would be nice if that was minus 13 volts, huh? Yeah, I'm gonna need to check some things, because I don't think I actually have any sounds yet. First mistake spotted. I just noticed in this diagram that signals when nothing is sent are at -15. And minus is always at ground. So I got that inverted. But that should be fixable in software. Okay, the CLP, the channel processor, memorizes the data every 12 microseconds because it 12 times 1 microsecond channels. So I need to guarantee the pulse width is that big. Okay, doing some analysis. Added connections to all the op-amp outputs and going through them. They're all good. This is what they're supposed to look like, except for one, which is a TL081, which should have enough slew rate, I believe, but I think I may have misread something, because this looks like it's way too slow. Right, I feel incredibly stupid right now. I accidentally defined the output pins as inputs. So basically what I was doing with my digital writing, because I'm using port manipulation, is setting pull up and pull downs basically via the MOSFETs in the output pins, rather than actually outputting signals. Now I've set these to output. It actually looks as perfectly fine. This is how it should be. So we got 5 volts coming from the Arduino, and we have around -14 coming from the op-amps. I only wasted 3 days on this. Okay, something is being played, but it doesn't sound like A440. But something is happening now. So, progress. Why do I always make things fart? What the hell? Well, I don't know about you. That sounds like a clean note. It's a little bit out of tune, but that's probably because the master oscillator doesn't have the tune knob connected. It says A4, which is an octave too high. But it is clean. Yeah, so I got the note clearly playing, but for some reason note off won't work. It was working before. It was giving me some trouble. I'm just putting everything through the logic analyzer that's coming out of the Arduino. And yeah, I just see the notes being played here. Okay, I know why I get all the weird random garbled notes. It's because this is quite sensitive for changes in ground. Turning it off and then on too quickly again seems to mess up the digital circuitry. So by being a little bit more patient and waiting for everything to settle, when it's shut down and then turning it on again, that definitely seems to stabilize things, because I'm getting a consistent note every single time now. Progress, but I still can't get the note off to work for some reason. Right, looking at this, I think here is the moment of power on. I had to kind of time it by turning things on with my toe and pressing record on this. But I think we have power on over here. And some random garbage happens. We have the Arduino turning on here. And it takes around 2 seconds for the actual clock to start. Before that, there's some garbage happening there. So I should be able to see it here. Okay, Arduino's doing stuff. We got some notes sending out. And then I see here on the 4 note channels, those are what amounts to high for the Yamaha. These are all low. Okay, that's correct. And then it stops sending. Now it's working. Okay, so it does indeed seem I need to send the SL reset code every 8 cycles of the T counter. That didn't work at all before, but it works now. Okay, we have an sort of an A4 turning on and off. Is it gonna work? I'm gonna do the big toe. Ignore the G, that's just 50 Hertz bleeding through. I think it's finally starting to work. Okay, I built an optocoupler and now sending MIDI data from Reaper via my audio interface through the optocoupler to the Arduino to the E-70. And as you can hear, it is working. Now I do wonder what happens when I do this. This third note seems to cut off when this note cuts off. So, okay, it's getting a little bit annoying. So, there's still a bit of a weird issue with note off. Maybe due to the data shift on the note off. But hey, it's working for 95%, I'd say. Oops, I just noticed another issue. Okay, so the C notes are the wrong octave. Yeah, that's because it has a very weird arrangement for the C notes. So I figured I would get that wrong, and I did. So I need to fix that too. Okay, 90% there. Right, so the E-70 is now MIDI-fied. Details and instructions will be on the deep dive and mods page on my website. See comments below. And have fun modding. See you next episode.